So we're going to start on Chapter 8 right now, page 215. Again, I already said this to you. An array is a type of collection. And as it says, they act as containers. All right? And it says, basically, the more complex applications you write, the more the chances are you're going to need some kind of a container. You just will. All right? And they give you some examples, which is fine. And as the author says in this chapter, you'll learn the basic concepts and techniques for working with arrays and some other types of collections. All right. So, first thing that we'll talk about in here is working with one-dimensional arrays. Now, I want to show you something. If you would, please take a look up here. I'm going to grab, this is the program we were just working on. I'm going to do a save all. And I'm going to close the solution. All right, now I'm going to bring up, this is the one that we'll create as a class tomorrow, but just so you see it. All right, so give me my numbers. There they are. Show me the sum of all those numbers. Show me the average of all those numbers. Lowest number, the highest number, the median number, the range, sorting it in descending, sorting it in ascending, etc. Does all that make sense? Well, what I want you to realize, if you look up on the screen, that's a one-dimensional array. All right? There are many rows, but there's only one column. I've had this talk before, and people have told me, in fact, it was interesting. One time, I had a young lady who came up and said, you know, Mr. Scott, I'm really struggling with arrays, especially two-dimensional arrays. I just don't get them. Okay? So we went back to her seat, and lo and behold, because I was going to ask her this first, she's got a spreadsheet up there. Guess what that is? That's a two-dimensional array. Those are columns. Those are rows. The only difference is that the rows start with 0 in programming, and guess what? The columns are numbered as well. They're not lettered. They start with 0. So see this location right here? It says up there that it's location A1. You see that? For us, it's location 0, 0. This would be 0, 1, 0, 2, etc. This would be 1, 0, 2, 0, etc. You can have arrays of as many dimensions as you need to have. I have never seen a program that has arrays of more than 4 dimensions. In fact, most people will not write a program with an array of 3 dimensions because it's hard to write a program for something you can't visualize. All right? And again, you know, over the years, it's funny. There's a site out there. I don't care if you guys see it. I don't care if you guys use it. But it's interesting because somebody told me about it. And it's called, I think it's ratemyprofessor.com. Okay, there it is. And I'm on there, not from here, but from my old job. All right, and one person had written on there, he seems, what was it? He seems like he's so-and-so, but when you get to understand his sense of humor, he's not a bad guy, and all stuff like that. Okay, well, the reason I'm telling you that is right around the time that that review was written, because I remembered it as a joke, we were talking about arrays, and I told students, I said, oh, we talked about 3-dimensional arrays, and I showed them. We talked about 4-dimensional arrays, and I showed them. I asked them to draw a 4-dimensional array. It was a joke. And I had 3 or 4 people come in on Monday. You know, I spent 3 hours on this thing. I can't draw in 4D. It was a joke. I don't know how you can draw in 4D. I don't think we've come to that point yet in the world. Oh, it was a joke? Wow, thanks for screwing up my weekend. Okay, sorry, I didn't mean to screw up your weekend. All right, so we are going to talk about first about one-dimensional arrays. Then we'll talk about rectangular arrays. What does that mean? That means that every row has the same number of columns. But you don't have to do that if you don't want to. you can have an array with a certain number of rows, and the columns can have different numbers. For instance, what if I had a thing for my rows? Let's just say I have 10 classes. Okay, I'm teaching 10 classes. One class I got 25 people. The next one I got 15. The next one I got 50. And I'm doing grades. You see how that would be different numbers? That's called a jagged array. All right. Then there's some, guess what? We've already started to do this. Use the array class. You already used array.sort, array.reverse. You've already used some of that stuff. All right. How to refer and copy arrays, how to code methods that work with arrays, how to use the null conditional operator. And the last stuff that's in here, the last approximately 15 pages or so, talk about non-arrays, but other types of collections. It's 9:53. I'll go till 10:15. We'll stop, and we'll take a break until 10:30. All right? All right. Again, I don't want to read to you. The author starts by talking about one-dimensional arrays. Now, when you look, he doesn't even draw a picture. But the funny thing is, I've seen people draw a one-dimensional array, and it looks like this. Kind of like the way we're doing it. They'll even put a dash between. And I've seen other people draw the same one, where it looks like this. And they'll have like 99, 88, 37. You get what I'm saying. And I've actually heard people argue over which one it actually looks like. You know, I remember listening to two people argue once, and I said, it's computer memory. It's virtual anyway. You have no idea. No, I know, but if we could see it, it would look like this. And I'm like, wow, that's like a really stupid argument. But, you know, go to it, I guess. The point is, no one knows exactly what memory looks like. Not only that, whether it's this or something else, it's not 99. It's the zeros and ones, because that's all the computer can understand, that make up 99. So actually for 99, it would be what? 1, let's see, 2, 4, 8, 16, 16, 32, 64. So that would be 96, 97. That's actually the number 99 in machine language. 1, 1, 1, 1, 2, 0, 4s, 0, 8s, 0, 16s, 132, and 164. 64 plus 32 plus 2 plus 1 equals 99. All right? That used to be, when people first started to program, that's how they had to program everything. Was with zeros and ones. All right. So they show some examples. The key takeaway right here is when you do this, you say the array type, bracket, bracket, and the array name. All right? And you can, so that will declare it. This will initialize it. You can do it in 2 statements or in 1 statement. And I've given you reasons why you might, so you can do it like this or like this. And again, so why would you ever want to do it in 2 statements? If it's a console program, I might say, how many students are in this class when I'm running it? Then this number would be how many students are in the class. So I may want to do it over 2 statements. Or I may already know and just want to do it in 1 statement. You can create arrays of virtually any kind of variable. And really, a multi-dimensional array, a 2-dimensional array, is an array of arrays. That's what it really is. And a 3-dimensional would be an array of arrays, etc. All right? Now notice, if you don't give your arrays default values, that C# initializes them for you. It's kind of nice. So numbers, they're automatically all 0. Chars, automatically the null character. Boolean, they're all false. If it's a string, it's the empty string. Okay? So as it says, an array holds what are called typically array elements. All right, that's usually the name that's used. The length or the size of the array is the number of elements in the array. in the array that we did, all right, in the array that we did, I don't know if you, in the program we just finished, max was set to 25. All right. But when we said array.length, we said less than that 25. Why? Because we start counting at 0. But again, if I say count to 10 and you go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, that's still 10 things. Whether I do it that way or I say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. When you create an array, again, each element of the array is set to a default value. If the array contains types, each element is the type shown here. First important thing. See that? You can't mix types. So in other words, I can't have an array that holds both strings and numbers and Booleans. You get what I'm saying? These two took a class last semester where the last 9 weeks we went over JavaScript. In JavaScript, arrays can have different kinds of members because it's written differently, but not this language. This is what's called a strongly typed language, so the system needs to know. Okay? So how to assign values to an array? All right, so here's an example. That's creating an array, and that array by default has what? 4 things in it. Thing 0, thing 1, thing 2, and thing 3. Right now, after that line executes that's in blue, each one of those holds the value 0.0. But now I'm giving each one of them an actual value. If I try to do this, the author says I'm going to get an error because I only have 4 locations and I'm trying to put something into location 5. All right, I've used this before and I said to people, it's the old saying, try to throw 10 pounds worth into a 5-pound bag. Well, if you do that here, the system does not allow you to do that. And literally it'll throw, this is an actual word, an index out of range exception. It is also totally legal that when you set up an array, you can give it values. See this? Notice when you do that, you don't put a number in here. There's no numbers. This one, I would never have said new decimal like this, 4. No, I would just do it like this, equals this. I've never in my life seen a person who uses the first syntax, ever. That doesn't make sense. It's more than you have to type. You do it the second way. But notice the second and third ways. If you decide you're going to initialize an array, all the values go inside of curly braces. Not brackets, curly braces. And that's pretty much what they say in here. Again, I don't want to sit and read it to you. All right. Notice here, this is something fairly new in C#. You see that word that before grades? It's called var. What that means is, hey, there's a whole number, there's a whole number, there's a whole number, and there's a whole number. Would you agree? There's 4 whole numbers in here. So the system can infer that it's an array of ints. That's what, if you want to use var, you can. Some people like that. Some people get confused by that. You're just starting out. I'd suggest probably not using it. All right. So here's some work with arrays. And guess what? We've done a lot of this stuff already. Because they talk about how to compute an average of an array. They talk about how you can get all how to put numbers in an array. How to add numbers that are in an array. You've already done this. Right? The length property, notice this is an important point. See this? It says using the length property. It is literally, it is a property of an array. Just like your height and weight are properties of you, your eye color and hair color, the length, which is how many members are in the array, is a property of the array. So they give you some examples. Again, I think the ones we went over are better than the ones that are in the book here. Here they just have you throw in 4 numbers. and they give you the sum and they give you the average. Now, one thing that's unique here, there's another kind of for loop you can use. It's called for each, and a lot of people get really confused by this. You look up on the screen and you look at this example right here. For each, int number in numbers. What's numbers? That's the name of the array. What's int? We just made it up on the fly. You could have called it Bob and it would work fine. Then it would have said int Bob in numbers, number string plus equal Bob plus this. You could have done that. With the for each loop, it processes faster internally than a for loop does. That's why you might want to use it. But, this is the important part. With a for each, you cannot change the value of anything in the array inside of the loop. Did you hear that? If you want to change the value of anything inside of the loop, you must use a regular for loop, or a while loop, or a do while loop. If you're not going to change the value, just want to print it out or whatever, you can use a for each. All right? And again, they give you an example of it, okay? You can use a for each loop, it says there, to access each element of an array. You can also use them to work with collections that we'll talk about at the end of the chapter. Okay, now we're going to go into rectangular arrays, but one thing I do want to mention to you. I'm going to give you a couple terms right now. They're not even in your book, but I want you to hear these, okay? If I come in and create an array, so I come in here, and I'm not going to put names in here, but let's assume we do this. So I'm going to come in here and I'm going to say this. Int bracket bracket grades. And let's say that you just all took a test. And one person got a 93, one got a 96, one got a 97, and one got 100. I don't care who those people are. Okay? I don't care. All right? But what I'm telling you is that in this, once I'm running this program, I can change this value or this value or this value or this value. I could change all of them if I wanted to. Maybe I decided that one question was too hard. So I made that one question worth more points. So the whole test now is worth 125 points. So, you know, maybe I do some weighting, etc. You see what I'm saying? But I can change this. I can change this, this, or this. What I can't change is I can't change the size of the array. All right? Arrays are what are called early binded. And that means at compile time, so when the program is converting, I should put time there. When the program is converting what you put in into the zeros and ones the computer can understand, you cannot change the size of an array. If something is early binded like this, it's set at compile time, you can't change its size. What we're going to get to by the end of the chapter is we're going to talk not about arrays. So again, arrays are early binded. A little later, we're going to talk about lists. Lists are late binded. So they're done at runtime. What that means is as the program is running, they can grow and they can shrink. So in that way, they're more powerful. All right? And, you know, I mean, if you add it as an example, I'm not saying true or false. We all know it's true. We started with 5 in here. We shrank to 4, right? Okay. Now, if we were using an array, then probably I have to take Christian and give him zeros for all of his tests. But he's not in here anymore, so it really doesn't make any sense to do that. So we, you know, with a list, you can add and remove things. Not just the values that are in there, but you can add whole things and remove whole things. So if we had 5 of you in here, and let's say that somebody else got an 89, and he's gone now, we can just do that. But you can't do that with an array. All right? I don't know if the book even gets into that. When I learned this stuff, the instructor that I had just went nuts over late binding and early binding and stuff like that. And it's always stuck with me. All right. So, it says, so far we've learned to work with an array that uses one index, but it is possible to create one with 2, as I already mentioned to you. All right. It says, although it's possible to create ones that have more than 2, typically you don't have to. It always will depend on the size and type of the project you're working with, okay, and how complex it is. For instance, what if each one of you is a salesperson, okay? Well, I could have an array with all 4 of you in there, right? But what if each one of you has some regions that are your own and some regions that you share? That might entitle a 2-dimensional array, all right? And there might be a case for a 3 or a 4-dimensional array. Again, I've never even used a 4-dimensional. I've never had to. I've used 3-dimensional arrays already. Okay, and it's a little hinky as far as the way that it looks. You'll see that in a minute. When you assign values, look at the difference. Here is a 1-dimensional array. Well, you've already seen it. Here's like a 2-dimensional array. There's 2 different numbers in there. See that? 0, 0, 0, 1, 1, 0, 1, 1, 2, 0, 2, 1. What does that mean? There are 3 rows, row 0, row 1, and row 2. There are 2 columns, column 0 and column 1. If you multiply the number of rows by the number of columns, you always get the number of elements in the array. Since this is 3 by 2, there has to be 6 elements. All right. And look, if you look on the screen here, looks kind of ugly. So if you are pre-initializing the array, you say comma in here to show that there's 2 of them, and you put each one of these into their own sets of curly braces, and you surround the whole thing with curly braces. All right? And you could put them over multiple lines if you want to. You know, it doesn't really matter. So as it says, a rectangular array uses 2 indexes, so it's a 2-dimensional array. How to work with them. The thing to remember, because I've had people ask me this, is the first number that's in a 2-dimensional array represents the number of rows. The second number represents the number of columns. But I've had people ask me, could I do it the other way if I wanted to? There's nothing that's literally stopping you, but virtually 100% of people, the first number is rows, the second number is columns. So if you change those, you're going to confuse people. All right, so I'd say you never should. And again, they give you some examples. Okay. There's a method called getLength that you can use, and it'll tell you how many rows or how many columns you have if you need to know those. Jagged arrays I mentioned earlier, when not every row has the same number of columns in there. That's a jagged array. And again, people oftentimes say, well, why would you ever want to do that? It always is going to be driven by what your problem is and how you're trying to solve it. That's all. So if you look at the example they have here halfway down on page 229, you'll notice this first one has 3 values, the next one has 4 values, the next one has 2 values. Again, if it's 3 of you that are in here, maybe Dominic has 3 different areas, maybe Maya has 4 different areas, maybe Angie has 2 different areas, etc. I don't know. So there's a lot of different ways this can potentially be used. As the author says here, you can use a jagged array to store data in a table that has rows of unequal lengths. And they give an example here on how you can work with those. Okay. It says since the number of columns in each row of a jagged array varies, you can't use a getLength method because it'll give you a different number for each one. All right, so instead you use the length property of the array. You do check them one at a time. All right, this seems like a good place. It's 10:12. Let's come back, please, let's make it 10:27. Okay, and we'll pick it up on page 232, more skills for working with arrays.